Kia ora Year 13. This is the first video that I'm doing in ages for stats, and I've decided to try doing a few during the holidays while I've got a bit of time. This one is going to look at the normal distribution. I'm going to focus them on high achieved, low merit kind of skills. I'm only going to make them if I get feedback that you guys want them. Otherwise, I'm going to put my time into calculus and my Cambridge class. So please let me know if this is helpful. Hopefully it will be. So I thought we'd start with one where you know the mean of a normal distribution and you have to find the standard deviation. This is actually a level 2 skill, but it comes up quite often at level 3. And it's really good for practicing some big ideas with normal distributions. So we've got kiwi fruit at Pack and Save normally distributed with a mean weight of 105 grams. Okay, 15% of them weigh more than 127 grams. So first we're asked to work out the standard deviation of the kiwi fruit weights, and then we have to use that information to figure out what proportion weigh below 80 grams. So a couple of things to just refresh your brains with. That's a very badly drawn normal distribution. I'm going to draw two pictures. One is X and one is Z. So X is what we use to label the thing. So here, X is equal to the kiwi fruit weights. And for a normal distribution, we have two parameters. We've got mu and we've got sigma. To figure out probabilities, we need to know both of those things. So mu is fine, we know that it's 105, and we can mark that straight away onto my picture. Usually, we write in sigma is equal to whatever somewhere here. But in this case, we haven't got sigma. So what we have to do is to figure out the sigma value from this information in the question. We know that 15% of kiwi fruit weigh above 127 grams. So here's 127 grams, and we know that the probability in that tail is equal to 0.15. Now, to solve this problem, we're going to use the standard normal distribution. The standard normal distribution has got a mean of 0 and a sigma of 1. And it's what we use for all our normal calculations when you shove them into the calculator. It does all of this calculating for you, but sometimes we have to do it by hand. So what we're going to do is to figure out what is the Z value that will have 15% in this tail. In other words, how many standard deviations above the mean must I be to get 15% in the tail? So there are two ways to do this. One of them uses your calculator and one uses the table. So we're going to go through how you do it using the table on the next slide. Okay, the key thing to remember about the table, when I can draw my Z picture, is that I've got 15% in this tail. So the table gives me all of the values for the standard normal. Right? So you've got a table and it's got all these numbers in here. But the table is set up to give you areas between 0 and the value. So before we go racing off to our table to look for 0.15, we need to slow down because the table number that we want is 0.35. So where does 0.35 come from? Well, we know quite a lot about the normal distribution by now, hopefully. Although, having just marked your tests, I do wonder, but never mind. There we go, we've got 0.5 on that side. So we know that this bit in here must be the leftover bit after 0.15, in other words 0.35. So now I want to go down into my table values and find the Z value that gives me an area of 0.35. So I'm just going to write that 0.35 up here because I want it to be very clear to you that the 0.35 is a probability, and it's this probability. It's a probability of being between 0 and some number that I'm going to write as little z. So this is what I'm hunting for in my table. So when we look through, you'll find that at about 1 point, where are we? We're looking for 0.35. When we get to 1.03, we get a Z value in here of 0.3485. So we're getting really close. And when we go up to 1.04, we're getting 0.3508. So the Z value that we want is somewhere between those two numbers. So now I go over to those funny little numbers on the side of my table and I figure out how much I want to add on to the 1.03. And you'll find that at 1.036, we're pretty close. So that's good enough for my Z value. All right, so this Z value here is going to be 1.036. Now finally we're ready to use that Z value to answer our question about the standard deviation. Okay, so I'm going to draw the two pictures again. This is my X, centered at a mean of 105, and this is my Z value. And we know now that when my Z value is 1.036, I'm going to have 15% in the tail there and 35% there. So where does the Z thing come from? Well, Z tells me how many standard deviations I am above the mean. So what we're saying is that 127 grams is 1 and a bit standard deviations above the mean. If you haven't got that intuition yet, that's fine, because we're just going to use this formula to move now between Z and X. So working this through, we get 1.036 sigma is equal to 22. Right, so the difference here, the 22, is 1.036 times the standard deviation. Now dividing both sides by 1.036 gives me a sigma of 21.2, and I've rounded that to 1 dp. Okay, so that's the first part of the problem done. Now we were asked to figure out what proportion of kiwi fruit weigh less than 80 grams. And that's going to be really easy now. We can do that straight into our graphics calculator because we know mu and sigma. So that's coming up on the next slide. So we want to find probability that X is less than 80. Please, please write some working down like that. So we can draw now. Here's X. This is 105. Sigma is equal to 21.2. And so we're going to colour in this tail here. So we can pop that straight into your graphics calculator and you should get, let's see, about 0.119, which is 11.9%. Okay, I say usually go to 4 dp. If you're doing it with a table, then it would go like this. Z is equal to 80 minus 105 over 21.2, which works out to give me, what does that give me for a Z value? Okay, so that gives a Z value of negative 1.18. So in either case, we end up getting from either the table or the calculator the same answer, which is a good thing. Alright, thanks for watching. If you have watched this and you found it helpful, especially if you've made it to the end, could you please send me an email so that I know that you're watching? It's quite hard to tell from the YouTube analytics module when people are finding these useful and when they're not, because people tend not to leave comments. So if you could just flick me a quick email to this address, and I'll do more if you're going to find them useful, but otherwise I won't worry. Thanks.